Let's see the last one, that is linear and non-linear systems. A system is said to be linear if it satisfies principle of superposition and homogeneity. So linear system means it should satisfy principle of superposition and homogeneity. Okay. Now superposition principle says, superposition principle. Now this says if you have two signals, let it be x1 of t, output be y1 of t. Second input x2 of t, corresponding output be y2 of t. Then if you add these two input signals, x1 of t and x2 of t, and pass it through the system, then you should get that will be equal to individually adding these two outputs. This is principle of superposition. These two will be equal. Now next is homogeneity principle. Now this says if you have two inputs x1 of t, corresponding output be y1 of t. Second input x2 of t, corresponding output be y2 of t. Then you multiply your first signal with x1 of t. That should be equal to multiplying your first output y1 of t by the same constant. Similarly, a2 x2 of t should be equal to a2 y2 of t. That means multiplying input by a constant should be equal to multiplying output by the same constant. This is principle of homogeneity. Now, if you combine these two, then you can write a1 x1 of t plus a2 x2 of t should be equal to a1 y1 of t plus a2 y2 of t. This is when you combine principle of superposition and homogeneity, you will be getting this. So your linear system satisfies this condition means if you have to check linearity, what you do is take x1 of t, multiply with the constant a1. The output will be a1 x1 of t. Take x2 of t, multiply with another constant a2. Output be a2 x2 of t. Then you add it together. When you add this together, you will be getting x3 of t. This is the weighted sum of x1 of t plus and weighted sum of x2 of t. Weighted sum means multiplying with a constant and adding. So this is let this be your new input now. That is equal to weighted sum of previous two inputs, that is a1 x1 of t plus a2 x2 of t. Now you pass it through your system. Now what you are supposed to get is y3 of t, which will be equal to response of a1 x1 of t plus a2 x2 of t. Now the same way, you take two inputs x1 of t, x2 of t. First you pass the inputs through the system h. Now you get what y1 of t and y2 of t. Then you multiply with the constant a1. You multiply with the constant a2. Now it will be equal to a1 y1 of t. Here it will be equal to a2 y2 of t. Now you add it together. So now when you add, you're getting a1 y1 of t plus a2 y2 of t. Now I am writing it as y4 of t. Now if these two are equal, that is if y3 of t is equal to y4 of t, implies a response of a1 x1 of t plus a2 x2 of t should be equal to a1 y1 of t plus a2 y2 of t. That is response of a system to weighted sum of inputs. Response to weighted sum of inputs should be equal to weighted sum of responses to individual input. This is a linearity principle, and this is how you will check whether system is linear or not. Response to weighted sum of input should be equal to weighted sum of responses to individual input. So first you have to take two signals x1 of t and x2 of t, multiply it with two constants a1, a2 respectively, then you pass it through a system. Then that response should be equal to individually taking the response of these two signals and then multiplying it with constants, and finally you have to add it. So if these two are equal, then the system becomes linear. This is the condition for linearity. This is the condition for linearity. So we will see one